welcome you all to the physics class. Okay, so now we are going to work out the book exercise from chapter 3, that is motion in straight line. Okay, so in the lessons we have studied about the accelerations and the kinematic equations and the various type of accelerations, that is uniform acceleration, non-uniform acceleration, constant acceleration, zero accelerations. Okay, after the acceleration, the next we saw it's kinematic equations. From the kinematic equations, we have worked out the three equations. Okay, then we have worked out the same kinematic equations from calculus methods, both integral and differential calculus. Okay, so after that, the Galileo's law of odd number out, and then stopping distance, then relative velocity, reaction time, and then relative velocity. Okay, now we are going to solve the book back exercise in that question number 7. Look at the question. Two trains A and B of length 400 meters. Okay, we have two trains. The solution is two trains A and B of same length. So train A and train B both have equal length, that is 400 meter. Train A also 400 meter, train B also 400 meter. Each are moving on two parallel tracks. So this is one parallel track. This is a second track. So the two tracks also parallel tracks. So two train also moving on a parallel track with the uniform speed of 72 kilometers. So the speed of the train A, that is same to the train B also. That is both 72 kilometer per hour. Okay, in the same direction with A ahead of B. So A is the train A is moving forward, then train B. Now the driver of train B decided to overtake A and accelerate by 1 meter per second. So A is ahead of B, but driver B wants to overtake A so that he applies an acceleration of 1 meter per second square. If after 50 seconds the guard of B just brushes past the driver A, so after 50 seconds the guard in the train B, okay, he just brushes past the driver of A. In that cases, what was the original distance between the two trains? Okay, so very simple things. We have a two parallel tracks, and the two parallel tracks, two trains A and B of equal length moving parallelly with a equal speed. But train A is forward, train B is behind it. After 50 seconds, train B, the driver from the train B, moving with an acceleration of 1 meter per second square within a 50 seconds, and it takes overtakes the A. In that cases, what is the original distance between the two trains? So this is a concept. So we want to find the original distance between the two trains. Okay, first we'll write the given data. So given. Okay, what is given? The length of train A, which is equal to length of train B, both also 400 meter. Okay, and then the initial velocity of the train. Initial velocity of trains, both also same. Initial velocity of A, which is equal to initial velocity of B. What is it? That is 74 kilometer per hour. So this we want to convert it into meter per second. So how you convert kilometer per hour into meter per second? 5 by 18 into 5 by 18. So by multiplying this value with the 5 by 18, we can convert kilometer per hour into meter per second. Then it's a 1 time, it's a 4 time. So the initial velocity is 20 meter per second. Okay, this is a given. Now we want to find the two things. First one, look at the solutions. This is a given. Now only the solution starts. Okay, the distance by train A in 50 seconds. That is accelerated or unaccelerated, both also moving with the same speed. So this case, we want to find the distance by train A in 50 seconds. As for an unaccelerated motions, it is very important things. Train A is not accelerated, only B is accelerated. Okay, B only overtakes A with an acceleration. So A is unaccelerated motions. Unaccelerated motion. We can find the distance. What is the formula? Distance is equal to speed into time. Since speed is equal to distance by time, so distance is equal to speed into time. Speed into time. So the speed only is initial velocity we are considered. So what is it? So the initial velocity is, so the distance by train A is speed into time. What is the speed? It is 20 meter per second and the time is 50 seconds. So second and second cancel. So the initial distance by train A is 20 into 50 is 1000 meter. Okay. Similarly, we want to find the distance by train B in 50 seconds, but train B is accelerated. Okay, train B is accelerated. So as for an accelerated motions, what would be the distance? Distance by train B is S is equal to ut plus half at square, no? So ut plus half A acceleration by train B of t square. So substitute the value. So ut, it is, what is the initial velocity? It is 20 meter per second into 50 seconds. So second cancel, plus half into A. What is the acceleration? It's a 1 meter per second square. 1 meter per second square into time is 50 square. So 50 into 50. 50 into 50. What is the unit? Second square. So second square. Here also it's cancelled. So 20 meter into 50 meter, it is 1000 meter plus this we can eliminate. So 25 into 50 meter. What is it? So 25 into 50. How much? Multiply. 50 into 25. So 0, 25, 0. Okay. So 1250. 1250 meter. So all together, the distance covered by train B for an uniform accelerated motions, that is the accelerated motions A is 1 meter per second square. In that cases, the distance covered by train B is 2250 meter. So the distance covered by train also we found, distance covered by train B also we found. But they are asking the original distance between train A and train B. Finally, train A is behind, but train B is forward, because after 50 seconds, with the uniform acceleration of 1 meter per second square, train B overtakes train A. So the original distance between the two trainers original distance between trains. What is the original distance between the trains? Which is equal to distance by train B minus distance by train A. So which is equal to 2250 meter minus 1000 meter. So the original distance is 1250 meter. Are you clear? I think you are very clear. It's a very simple concept. Two train also moving in a parallel track. Okay, in which train A both also moving with the same speed and both the length also same. Both also moving with the same speed of 74 km per hour. Both have 400 meter length. So we doesn't consider the length. Okay, we should consider only one thing. So A is moving ahead of B, but after 50 seconds, the train B is accelerated with a 1 meter per second square, and it overtakes train A. What is the original distance between these two cases? So separately we found the distance traveled by train A for an unaccelerated motion. It is 1000 meter. Then distance traveled by train B in 50 seconds for an accelerated motion is 2250 meter. So the original distance between both the trains we found. There is another one alternative method is there. Listen, this is one method. In two ways we can solve this. Okay, in two ways we can solve this question. One method, this is one method. Then the second method is, listen, we can cross check that. Okay. So the original distance between the two trains, initially the initial velocities we assume already it's in motion. So the initial velocity we assume it is 0. So the original distance between the train is equal to ut plus of 80 square. Okay. So already the two train is moving with the same speed. So that will be a final velocity. So the initial velocity would be 0. So by assuming the initial velocity is 0, so 0 into 50 seconds plus half into, what is the accelerated motions? 1 meter per second square, and 50 into 50 second square. So second square cancel. And this is 0 plus, this is 25 into 50. What is it? 1250 meter. So 1250 meter is the original distance between the two trains. This is the alternative method. Okay. Coming to the question number 8. Look at the question carefully. On a 2-lane road, okay, first we'll write the given. On a 2-lane road, car A is traveling with the speed of 36 km. This is 2-lane road. Okay. On a 2-lane road, car A is traveling. So car A is traveling with the speed of 36 km per hour. So the initial velocity of car A is given. Two cars B and C approaches car A in opposite directions. So on this 2-lane road, first the car A is moving with the speed of 36 km per hour. Two cars B and C approaches car A in opposite directions. So car B approaches A, with that C also approaches A. Okay, so car B and car C moving with the opposite direction. Okay, moving in opposite directions with the speed of, this is UB and UC, both also same, with the speed of 54 km per hour each. At a certain instant, when the distance AB and AC is equal to 1 km, the distance AB and the distance AC is equal to 1 km. Okay, so we'll write here. This is car C. So at a certain distance, at a certain instance, when the distance AB and the distance AC is equal to 1 km, now only the question begins. B decides to overtake A. Who decides to overtake? B decides to overtake A before the C does. Okay, அதாவது C A reach பண்றதுக்கு முன்னாடியே B tried to overtake A. Okay. And what is the minimum acceleration of car B is required to avoid an accident? So we want to find the minimum acceleration of car B to avoid an accident, because B and C coming in opposite direction, no? So we should find the minimum acceleration of car B to avoid an accident. Are you clear about the questions? I repeat once again. There is a two-lane road. First, car A is moving with the speed of 36 km per hour. Okay. And two cars B and C approaches A in opposite directions with the equal speed. Okay, this is car C. This is the equal speed. What is the speed? 54 km per hour. Okay. At a certain instance, when the distance AB and the distance AC is equal to 1 km. So B decides to overtake A before the C does. In that cases, what is the minimum acceleration of car B to avoid an accident? Okay. So first we'll write the given data. So the diagram you are clear, I think. Okay. So here given the speed of car A. What is the speed of car A? It is 36 km per hour. Convert into meter per second. So 5 by 18, no? So 36 into 5 by 18 meter per second. So the speed of the car is equal to, speed of the car A is equal to, so 1 time it's a 2. It is 10 meter per second. Similarly, the speed of car B and car C. This is speed of car B and car C. This is the speed of car A. Speed of car B comma C is given. That is speed of car is equal to speed of car C. What is the speed? 54 km per hour converted into meter per second. So the speed of car B is equal to speed of car C, which is equal to, convert this value into meter per second. So 5 by 18. So 1 times, 4 times, sorry, it's 3 times. So 3 18s are 54. So 3 5s are 15. So 15 meter per second. So this is the speed of car B and car C. Okay. So now only the solutions begins. Okay. So in the solutions, first we are going to find the, see, this is speed of car A, speed of car B, and in opposite directions, speed of car C. Okay. So we are going to find the relative velocity of car B with respect to A. Find the relative velocity of B with respect to A. So that is the relative velocity of B with respect to A is, what is it? Speed of car B minus speed of car A. Okay. What is the value? Speed of car B is 15 meter per second minus speed of car A is, what is the speed of car A? It's 10 meter per second. So the relative velocity is equal to 5 meter per second. Similarly, find the relative velocity of car C with respect to A. That is relative velocity of C with respect to A, which is equal to, what is it? Velocity of car C minus velocity of car A. But this is in same directions. Okay. In which directions A moves and the same directions the B also moves. But in that, now the second case is you are going to find the relative velocity. Relative velocity of car with respect to A, but moving in the same directions or in opposite directions. Opposite directions. So speed of car C, we know. What is the speed of car C? It is given 15 meter per second minus of, to C, A is in opposite direction. No? So already here minus is there. So A velocity is in opposite directions. What is the A velocity? It is minus 10 meter per second. Therefore, the relative velocity of C with respect to A is minus into minus plus. So it becomes 25 meter per second. So we got the relative velocity of both the cases. We'll write it separately. Okay. The next thing, B want to overtake A before C does. So what is the minimum acceleration? We should find the minimum acceleration. So that we'll write here. Okay. Better we'll rub and write. Because we don't want. Okay. So distance between A and B is given. So distance between AB, which is equal to AC, that is 1 kilometer, that is equal to 1000 meter. Okay. The next step, we want to find the time taken by C to reach AC. Time taken by C to reach time taken by C to travel a distance AC. Time taken by C to travel a distance AC. What is the formula? So time is equal to speed is equal to distance by time. So time is equal to distance by relative velocity of C with respect to A. So what is the distance? The AB and AC, it is 1000 meter, and this relative velocity also we found, it is 25 meter per second. So meter and meter cancel. This denominator time goes here. So it's a 1 times 4, 40. So what is the value? It is 40 seconds. So 40 seconds is the time taken by car C to travel a distance AC. Similarly, in another one step, we want to find, okay, now only the condition starts. Let car B start with an acceleration. Let car B start with an acceleration of A. Then what would be the distance? Then distance is equal to ut plus half at square, no? So we found both also. This is a separate relative velocity. This is the time taken. Okay. So here we can modify this. What is it? Yes. Relative velocity of B with respect to A into time plus half into acceleration of a car only we want to find, and time taken. So substitute all the value. So S is equal to, what is the relative velocity of car B with respect to A? It is 5 meter per second into time is 40 seconds. So second and second cancel, plus half into acceleration of a car, we don't know. So we don't know the acceleration of a car, but we know the distance. What is the distance? Original distance is 1000 meter. So 1000 meter into t square is 50 into 50. It is 2500 second square. Oh, sorry, not the 2500 second square. It is 40 into 40. So what is the 40 into 40? 1600 second square. Okay. So after rearranging, we can easily determine the acceleration of a car. So 1000 meter, which is equal to 200 meter plus half. We can cancel this now. So 200, 1600 becomes 800 second square. So acceleration of a car B into 800 second square. Therefore, this your transfer. This minus 200 you transfer that side. You'll get 800 meter is equal to 800 second square into acceleration. We want the acceleration of a car B, that is minimum acceleration of car B, to avoid an accident. So the acceleration of a car B is equal to 800 meter by 800 second square. So both cancel away. Finally, it is 1 meter per second square. So the minimum acceleration of car B to avoid an acceleration is 1 meter per second square. I repeat the question once again. Initially, car A is moving with some speed. In a two-lane road, on opposite direction, two car approaches. Car B approaches car A. At the same time, car C also approaches car A, but in opposite directions. Okay. And in that cases, the original distance between AB and AC is equal. Both also said to be 1 kilometer. Okay. And they given the both all the cars velocities in kilometer per hour. We need to convert it to meter per second. After that, first you find the relative velocity of car with respect to A. Both also in same direction, so directly we can get the value. But the relative velocity of car C with respect to A is in opposite direction. So A is opposite to that of C, so here we introduce minus. So we got the separate relative velocities. Now we want to find the time taken by car C to reach A. That would be the time taken by car A to reach B to reach A. So time taken is equal to distance by relative velocity. So from that we found the time taken. Using this time only, we are going to determine an acceleration by these conditions. Okay. Let B start with an acceleration of A because car B is going to approach us A. So from second equation of motions, substitute the values, then you can find an acceleration. So to avoid an accident, the minimum acceleration given by car B is 1 meter per second square. Next to question number 9. Look at question number 9. Two towns A and B are connected by a regular bus service. Okay, this is town A. Imagine it's a Namakkal. Another one town is Mohanur. That is town B is Mohanur. Okay, so the two towns A and B are connected by a regular bus service. A bus is flying from town A to town B and then town B to town B. So it is flying on either directions at every 10 minutes. So the bus, that is velocity of the bus, is flying at every 10 minutes on either directions from town A to town B and town B to town A. That is from Namakkal to Mohanur and Mohanur to Namakkal. A man cycling with the speed of 20 km per hour in the direction of A to B. Okay. So now a man is cycling. Now it's a holiday. So most of the boys and girls used to cycle on a highway road, no? Yes, it's the best exercise also. So a man is cycling from town A to B. So the velocity of cyclist from A to B. He noticed that a bus goes past in every 18 minutes in the direction of his motion. So in the direction of his motions, at every 18 minutes, he noticed that the bus is passed in the either directions. Okay. And in opposite direction at every 6 minutes. And in opposite directions at every 6 minutes. So at every 18 minutes, the bus goes on either directions. But in opposite directions, every 6 minutes once the bus reaches him in opposite directions. So what is the period of the bus service? Which is the speed does the bus fly on the road? So we want to determine two things. The time taken by bus and also speed of the bus. So two things we want to determine. Very simple questions. Only the concept we should clear. First read the question thoroughly. There are two towns, town A and town B, and the two towns are connected by a regular bus service. It may be a town bus or private bus. Okay. So the two towns are connected by a regular bus service. Okay. The bus is flying on a road on either directions. Okay. Either directions at every 10 minutes. Okay. And the speed, now the cyclist from the town A to town B is moving. So while he is moving, at every 18 minutes in the direction of his motion, he noticed the bus. So cyclist in the direction of அதே directionலயே bus போறது எவ்வளவு நேரத்துக்கு பார்த்திருக்காருன்னா 18 minutes once. So at every 18 minutes, the cyclist noticed the bus moving in the direction of his motions, and at every 6 minutes, he noticed that the bus is moving in a opposite direction. So what is the time taken by the bus services? That is the period of the bus services, and what speed the bus is flying on this road. Okay. So from this, first we'll write the given things, and the cyclist speed is given. What is the speed of the cyclist? It is 20 km per hour. Okay. So we want to solve this. Look at the solution. So in the direction of the motion of the cyclist, in the direction of the motion of cyclist, that is from A to B. We want to travel the two distance. Okay. So here the relative velocity of bus with respect to cyclist is equal to velocity of bus minus velocity of cyclist. Okay. So velocity of the bus we don't know, but the velocity of cyclist is 20. It's a kilometer, both also same unit, kilometer per hour. So this is equation number 1. Okay. And the bus goes past the cyclist after every 18 minutes. After every 18 minutes, the bus goes past the cyclist. This is cyclist. Okay. So in the cases, the distance covered by the bus with respect to cyclist. Distance covered by the cyclist with respect to distance covered by the bus or cyclist. Distance covered by the bus with respect to cyclist. What is it? Distance is equal to speed in time. Distance is equal to speed into time. So speed already we know, it's a relative velocity. Vb minus 20 kilometer per hour into, this is at the case of every 18 minutes. Okay. So time is minute, you convert it into hour. So divided by 60. So both cancel. So the value is Vb minus 20 kilometer, yes, kilometer per hour into 18 by 60. So into 18 by 60 kilometer. So this is equation number 2. Similarly, we want to determine distance covered by the bus. Okay. Similarly, we want to find the bus leaves in either direction. Second one, bus leaves in either direction. That is after every 3 minutes. So in the cases, distance traveled by the bus in 3 minutes. Distance travel by the bus in 3 minutes, which is equal to speed into time. So the velocity of the bus into t by 60, it's a kilometer. This is equation number 2. Okay. So both the equation represents the distance. So comparing these two equations, if the left hand sides are equal, automatically the right hand side are equal. So unequating these two equations from its right hand side, what you will get? Vb minus 20 into 18 by 60 kilometer, which is equal to Vb into t by 60 kilometer. Kilometer cancel. So finally we'll get this value alone, and the 60 also cancel. Therefore Vb minus 20, which is equal to Vb into t divided by 18. So this is equation number 3. We got the third equations. Next, look carefully. Okay, in one method only we have got the third equations. Actually, this is the case in the direction of the cyclist. The bus is moving from town A to B. Finally, we found one equations. Okay, so in the cases from town A to B, when a bus is moving, when a cyclist is moving, the bus also flying. So in that case, at every 18 minutes, the cyclist noticed that the buses crossed them. Okay, in the same direction, along its directions. Okay, so at every 18 minutes, what is the distance covered? We found it. Okay, and generally the distance traveled by the bus in t minutes, this is another one equation. Both also distance covered. So equating these two equations on the right hand side, we got one equation. Same like the second method, in the direction opposite to the motion of cyclist. In the direction, now the second case we are going to determine one equations. In the direction opposite to the motion of cyclist. That is from B to A, not from A to B, B to A. So in the cases, the velocity of bus with respect to cyclist, so minus of minus Vc, so it becomes, it's a 20, no? So minus of minus 20, it's a kilometer per hour. So minus into minus becomes plus. So this is equation number 4. Now this is equation number 4. Okay. So in opposite directions, the distance covered by the bus with respect to cyclist, this is after every 6 minutes. So the cyclist noticed that at every 6 minutes in opposite directions. So the distance is equal to speed into time. So speed into time. Here time is 6 minutes. So 6 by 16. So 6 by 16. So we got equation, this is equation number 5. Similarly, this won't change. The bus leaves in either direction. So the distance traveled by the bus in 2 minutes is velocity of the bus and the time taken. Okay, so distance is equal to speed into time. Now equate these two equations. Compare these two equations. Equation 5 and 6 are same. Equation 5 and 6 are same. So equating equation 5 and 6. Equating equations 5 and 6 on the right hand side. What we'll get? Now we are going to equate. And equating the right hand side of the two equations. This is plus. So velocity of bus B plus 20 into 6 by 60 kilometer, which is equal to velocity of bus B into T by 60 kilometer. So kilometer by 60 we can eliminate. So finally we'll get velocity of bus plus 20, which is equal to velocity of bus into time t divided by 6. This is equation number 7. Now you're going to divide the two equations. Already we had a third equation, no? So divide equation 7 and third equation. So you're going to divide equation 7 by third equations. So what you will get? What is the seventh equation? On the both the side we'll have to divide, no? So velocity of bus B minus 20, sorry, this is plus, divided by velocity of bus B minus 20, which is equal to VB into T by 60. The denominator and numerator changes. So what is that equation? That equation is this is opposite direction 6 minutes, that is in 18 minutes. VB into T. So both cancel. Okay. And this we can eliminate. So using 3 tables, 60s are 18, 20, 2 3s are 6, 10. Okay. So 3 by 10. So 18 by 60 is equal to 3 by 10. Okay. Using cross multiplications, what you will get? VB plus 20 divided by VB minus 20, which is equal to 3 by 20. Using cross multiplications, 10 into VB plus 20, which is equal to 3 into VB minus 20. So 10 VB plus 200, which is equal to 3 VB minus 60. Okay, and this your transfer to this side. So what you will get? Then it become minus. So 7 VB is equal to, yes, 7 VB is equal to there is some changes. Wait. Know that already the third equation, that is on the direction of the cyclist, the bus is moving from town A to B. So town A to B, when a cyclist is moving on the direction of the buses from A to B. So already we found the equation, that is VB minus 20, which is equal to VB into T by 18. This is equation number 3. And equation 7 also we know. What is the seventh equation? Opposite directions. And opposite directions from town B to A to the cyclist. So this is at every 18 minutes he noticed. This is the equation at every 6 minutes he noticed. So in that cases, we found the equations VB plus 20 is equal to VB into T by 6. This is equation number 7. Now we are going to divide the two equations. Divide the two equations. Dividing equation 7 and 3, what do you will get? So VB plus 20 divided by VB minus 20, which is equal to VB into T by 6 into, this is become inverse. So 18 by VB into T. So VB into T, VB into T cancel. Then using cross multiplication, VB into 20, the denominator 8 is multiplied with this, 6 is multiplied with the left hand side. Similarly, already 18 is in the right hand side. This denominator goes to the right hand side. That becomes VB minus 20. Then multiply it inside. So what you will get? 6 VB plus 6 2s are 120, which is equal to 18 VB minus 360. Okay, 360. And then transfer this both the terms. This becomes this side and this value becomes that side. So you will get 18 VB minus 6 VB, which is equal to 360 minus 120. So minus 120 becomes this side. It's a plus 120. Just wait. 18 VB is here. The 6 VB are transferred to that side. Okay, it's transferred. Already 120 is there. Now, yes. So from the subtraction, we'll get it's a 12 VB is equal to 480. Yes, 12 VB is equal to 480. Therefore, the velocity of bus is 480 divided by 12. So 112. So 440. Therefore, the velocity of the bus we found. What is the velocity of the bus? Velocity of the, that is the speed of the bus is 40 km per hour. So we found the velocity of the bus. Okay. Next, we are going to determine the time period. So substitute this velocity in this equation, then you will get the time period. Okay. Then from 7th equation, velocity of the bus is 40 km per hour plus 20, which is equal to 40 into T by 6. Okay. So this is 60, which is equal to 40T by 6. So this 6 is multiplied here. 3600, which is equal to 40T. So 40T is equal to 3600 and T is equal to 360 by 40. 0 0 cancel and it is 9. Okay. So already we found the velocity of the bus. This velocity of the bus, you are going to substitute any one this equation. You can determine the time period. I substituted in the velocity of the bus in 7th equation. So while I am substituting the velocity of the bus in 7th equations, then finally I got the time period. So which is equal to 9 minutes. So T is equal to 9 minutes. So the time period of the bus services between the town is 9 minutes, and the speed of the bus is, what is the speed of the bus? It's a 40 km per hour. Thank you.